are working on standard 3 MBT 3, which is multiply one digit number by multiples of 10 in the range of 10 to 90. We're also working on MD7 and MD8, but the main standard is MBT 3. For our number talk today, what I want you to do is to create an array and make an equation for us. Create an array using the tiles and write an equation that is from the tiles that you model.
Any amount?
Any amount. Okay, you have your array and you have your equation. Could you talk with Ms. Brown about your array and the equation that you created to that matches your array?
Okay, well, I got my equation because when I lined them up in the array, I noticed that I have 4 tiles going down and I have 4 tiles going across. And so by me knowing my multiplication facts, I know that 4 times 4 is 16. And even if I use repeated addition, I know that 4 plus 4 is 8, plus 4 more is 12, plus 4 more is 16. So that's how I got my equation and my product.
Okay. Could you make another array with more tiles than what you have?
Keep these and just add to
Yes,
it?
add to it. And write a different equation for the new array that you're creating.
Okay. Now my new equation is 4, because I have 4 going down, and I have 6 tiles going across, and 4 times 6 is 24.
Okay, so how many do you have now? 24?
24.
Okay. Now, I saw you had the tiles on what you put here. You started at the bottom. Why'd you change?
I changed because I just didn't want to go back and pull some more. It would have been like this, and I was trying to not make it a perfect square, because I would have had 5 by 5, like I had the 4 by 4. So since I had 4, I just decided to turn them around.
So you made another column.
Yes.
Okay. My next question is, does it matter with this array if you turned it with the equation? Would the answer still be the same? I know the equation will change, but will the answer be the same?
It would.
Okay, could you turn that please so it will show a different equation?
Okay, now my equation is showing 6 times 4, which is still 24, because all I did was turned it or flipped it, as we say, using the commutative property. So I didn't take anything away from it. I I just turned it. So my
And-
answer remains the same.
Okay, so what we're gonna do today is extend what we already know through our number talks in our lesson for today. We do have the equations written correctly. We have the correct products for those equations that you wrote for those two arrays that you created. And we're going to extend that by using these very same tiles and multiplying this by 10.
All right, we're going to continue our lesson on the standard 3 MBT 3. We're trying to figure out, or we're working on strategies that we can use to multiply with multiples of 10. Now, previously we talked about creating arrays with just single digit numbers. Now we're moving on to multiplying by tens, multiplying a single digit number by tens. So first, what we need to do, I want you to know that this represents a 10. Okay, 10 little single cubes put together represents 110. So if we're multiplying by 10, we know that 1 times 110 would be what? 10. All right, so 2 of these would represent 20, 10, and 20. So if we're multiplying 3 tens, we have 30. 4 tens would represent
40.
5 tens would represent
50.
and so forth. Okay, so let's look up here. I've posed a problem. This problem says that Mrs. Travis offered free math tutoring classes for 5 days. Peyton attended the free tutoring classes for 30 minutes each day. How many minutes did Peyton attend the class? Now, it's 2 strategies that we're going to talk about. This first one deals with a number line, and the second one will deal with place value. So, Ronnie, if you would, let me put you on the spot. Come to the board for us, please. Now, in this problem, what numbers are we dealing with?
5 days and 30 minutes.
All right, from what you know so far, or what we've learned from our previous lessons, what do you think we're going to be doing with these numbers?
Multiplying.
All right, we're going to be multiplying, all right? So we have a number line right here. This number line is counted by what?
Tens.
By tens. All right, so this problem talks about 30-minute increments. All right, if you would, take this for me. Since we're talking about 30-minute increments and we're talking about 5 days, we're trying to figure out exactly how many minutes Peyton would attend classes. So, with the number line, we've learned in the past that we always start at 0, pretty much, okay? So, what I'd like for you to do is take the marker, start right here at 0, and hop to 30. All right. Now, if we're trying to figure out how many minutes he would attend classes for 5 days, if this is the first day he attended for 30 minutes, what would 30 more minutes be?
60.
Okay, so that would be the second day. What about 30 more minutes?
90 minutes.
90 minutes is correct. What about the fourth day?
120 minutes.
All right, and the fifth day?
150 minutes.
All right, so we see that Peyton attended class for 150 minutes for 5 days. And all we did was use what we already know. We're counting by tens, but in this case, we're talking about 30-minute increments. So we hopped by 30, 5 days, and we ended up at 150. That's how we can use the number line to help us with counting by multiples of 10. All right, if you follow me over here. Now, we've learned that each one of these represents tens, okay? So, this is another strategy we can use. It's just place value. All right? Now, if we know that 3 of these, if this is 10, this is 10, and this is 10, so these 3 make what?
30.
30. All right, so this represents 30 minutes for the first day, okay? So if we add this second group of 30, how many minutes is that?
60.
All right, so for the second day, that makes the 60 minutes. If we add another group of 30, then how many minutes is that?
It's 90 minutes.
That's 90 minutes. Let's add this fourth group of 30. How many is that?
It's 120.
Okay, I see you're checking. Let's see. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. So far, so good. Now let's add this fifth group of 30. Now what do we have?
150.
We have 150. All right, so this represents those 150 minutes that we figured out over here. So we've used the number line strategy as well as place value strategy to figure out how many minutes that Peyton spent in class for math tutoring. All right, now I have some problems that you all will do on your own, and I'm going to walk around and monitor to see which strategy works best for you. Are there any questions?
No, ma'am.
All right.
Recording, you gotta slide it up.
Okay.
Alright, so we talked about arrays, we talked about how we can use place value, and we talked about how we can find place value using a number line. Now, what we're gonna do next is we're gonna actually take a look at a word problem. And it reads that Krista solves 3 times 60 by understanding that 3 times 6 is 18. How can Krista use 3 times 6 equals 18 to solve 3 times 60? So this is what I want you guys to do. You're gonna get with your elbow partner and you're gonna go through this problem and you're gonna look at the important information you need to solve. Once you have solved that problem, you're gonna pair with that elbow partner and you're going to discuss your strategy of how Krista could have solved this problem. So everyone should have a pencil, everyone should have a sheet of paper, and I kind of want you just to go ahead and try this problem on your own first. Then we're gonna share with your partner what you went over. Then we're gonna discuss it together. All right, so tell me what you and your partner discussed.
Well, Ronnie told me, or he showed me by doing an array. He did a 3 by 6 array, which made 18. 3, 6, 9, 12, 15, 18. So we knew that. And so I took what I knew about tens, and what I did was I created 3 groups of 60. And When I counted my 3 groups of 60, I had 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140, 150, 160, 170, 180. So I know that 3 groups of 60 makes 180. And I guess the pattern I see is when our place value changes and we add tens to it, then our answer tends to increase with the 0. Our place value changes. We went from single digits 3 times 6 to 3 times 60, which changed our answer from 18 to 180.
Okay, let's take it a step further. What if, let's think in place value, and I know we're only discussing tens, but what if that problem was 3 times 600? How can we use place value to help solve that problem based off of what we already know?
Well, I guess like I said before, you kind of see a pattern. What I'm noticing is 3 times 6, we're dealing with 2 one-digit numbers, single digit numbers. In the second one, 3 times 60, we have a single digit and we're multiplying it by a 2-digit number which deals with ones and tens. And then in this new problem, we are multiplying a single digit number by hundreds. So if 3 times 6 was 18 and 3 times 60 was 180, and I see that, we added a 0 to each one, then my assumption would be that 3 times 600 would probably be 1800.
That's right. We did, as it is a pattern. And notice, like you said, it went from a single digit or the ones place to the tens place to the hundred place. So we basically were just looking at 6 times 3, which we already knew was 18. And we put in those place values of zeros, which made that number 1800. Now, with your partner, what I want you guys to do is, I want you to think of another strategy that you could use to help you solve place value based off the pattern that you see. Once you're done, you will take your work, you'll put it to the end of your desk, and I'll come around and collect